congratulations on pronouncing my name 100% correctly because my name is really tough.
Thank you.
Yeah. Yeah, I go for Nad, and by Nad, you can call me Nad. That's easier for everybody. I'm very excited to be here. I will be talking about error handling in Golang. Uh, I think it's a very interesting topic. I'd like to give a quick intro about myself. I work as a principal engineer at Route. I think most of you are familiar with Route. And I've been, I'm a technology enthusiast and evangelist for quite some time, doing talks and presentations and trainings and things like this. I started working with Go since the very beginning, since the very first versions. I remember downloading the first version and compiling it myself to check it out. And I was amazed with the language and the performance to compile, especially back there. I was doing a lot of code in C++. And you guys that have experience with big C++ project know that compiling a big C++ project can take like forever, right? And compiling a big source code in Go, it was fantastically fast. I have, I don't want to say that I'm that old, but I have more than 35 years developing software and having fun and creating bugs, because the fun part is to create a bug, find it, and then fix it, right? And yeah, I'm a huge Star Trek fan. For the people here that love Star Trek, yeah, count me in. Okay, I'll be talking a little. If I don't know the dynamics, how you guys would like to do it, but you can stop me at any time. Okay, it's not a long presentation because it's much more how we, my proposal and how I like to do, and we do in our team, handling errors in Go. And so you can stop me at any time. And if you don't understand anything, as I'm a Brazilian and the accent is completely different, please let me know. And then I try to repeat in a different way. Okay, no problem whatsoever. Okay, first of all, we have a small agenda here. It's like, what is a error in Go? Multiple types in error in Go, error handling Go, the idea of error and exception in Go, because a lot of people say that Go doesn't have exception. And I don't know how many fights or air code fights, but discussions or warm discussions about Go not having exceptions, and that's very bad because every single respectable language has exceptions, and it's not really true because Go does have exceptions if you want to use them. The normal way is not using exception, but you can. I'm going to mention about the performance impacts of using exceptions in Go and what we learned from it when using it in our projects, right? And I finished talking about a little about semantic error handling that I think is too important. Is really important to treat the concept of syntax error and semantic error in libraries, programs, and related. Okay. Any questions up to now? Perfect. Okay. What is a error in Go? A error is simply a building type, right? You can check it if it's new, and if it's not new, it's an error, right? And basically, the type error is an interface like this, and there is just one method defined that is the error method. So you basically can get anything and make it a error, right? And if we get the basic error here, I have an example. Uh, when we say errors.new and we give a tags here, what we are creating basically is this structure here, error string, that is defined here, error string, and it has a method called error, right? If I go here and I go for my first example here, when I say, can everybody see this or should I make it bigger?
A little bigger would be a good idea.
Yeah, just 1 second. Editor font. It's okay now?
That's great.
Okay, if we go here and say, if we enter here in this error new, we can see that's exactly this, right? Error new, it's a string. And then there is this error string type here. and there is this error that returns the string itself, right? And if I run it here, I just see down there, error main, this is an error as it's being printed here, right? Nothing fancy, quite normal stuff. And it's not coming back to the presentation, so just 1 second. Should come back. Oh, okay, yeah. You guys can see, right? Oh, perfect. Then we support, by doing this, we support multiple types of errors. We can implement several types of errors. For example, the error now for API calls, sys level API calls, right? Sys calls are also implemented like this. If I take the second example here, and I just do syscall error num and the number of the error. If we check here, error num is a type alias for unassigned int pointer, and then there is the error here that is basically going through this array here that has all the operational system error codes, and it will return the operational system error code that I have, right? If I run here this, I will get something like interrupted syscall, and I type 5 here, I will get input output error. Because on macOS, this is the constant, the values for DAOing, the operational system that defines the error node, right? Okay, if I continue here, then start the part that I want to focus, that is the syntactic part of error handling in Go. It was a very brief introduction, but I'm quite sure that everybody's familiar with it, how errors are defined in Go. And here we have a very simple example of error handling. We have a small program that says, I have a package main, I have errors in format, I have a context, error invalid argument, errors new main, valid argument. And then I do some computation. And if this error is different than new, then I panic, right? Otherwise I say, okay, everything will work. And if I see here the do work part, the computation work, is simply doing a for, calling unit of work, and if the arg is 0, it will return an error invalid argument for the sake of this example. Okay, nothing fancy. You don't even need to care about the algorithm. It's quite simple. It's just summing numbers. But it's very normal to have this idea of you passing parameters, you have the output, and you have an error here, right? With this, right? And if I run this example here, everything works just fine, right? But if I do like the syntax, the work is 0. Sorry. It's in the computation. I don't remember even on where it is, but it's here. Just if this gets 0 or less than 0, sorry, then it's less than 0. And it's not. So I don't remember how it generates arg equal to 0. It minus 1 and this. Oh, but I'm just printing. I'm not, yeah, I don't remember this. Sorry for that. It was just, the objective here is just to show the regular pattern that we follow. I was just copying and pasting some code, and I don't even know why it's not generating the error. But this is the normal way we do in Go, right? And my question to you guys, and what is the biggie with this? What is the problem, if there is any problem?
I think a lot of people just hate writing these if conditions. I know for a fact people get frustrated with that pattern.
Yeah, thank you a lot, because I already expect nobody to say anything, and I do this. Come on, what is the problem?
Yep.
I will give you a less change, but you already got it. It's syntax, right? It's like, yeah, it's exactly this. For example, this is from the AWS SDK. If we look at the AWS SDK here, I have from GitHub. Look at this. This is, in my humble opinion, kind of nuts because you have error stack serialize add this if error not equal no return error, and then you do stack deserialize add error not equal new then error this, and then you were doing this all the time, right? And especially people that come from languages that you can do a long jump, right? You're using basically you're raising an exception and you can stop the normal execution flow of the program. You're like, oh my God, I'm repeating myself all the time. And it's quite common. I do it all the time. Like sometimes we're doing like not equal to new, where you should write equal to no, to new, or otherwise, right? You are sometimes like you spend like 5 minutes, 10 minutes, and what is going on? And it's like you should have written not equal instead of equal, and you wrote equal instead of not equal, and vice versa, right? And this is something that happens, and this is a big criticism that people have with Go error handling. And before I learned about a different way of doing this in Go, I was a huge uh, sponsor trying to convince people that this was not a big deal. It was like the way Rob Pike and the creators of the language envisioned the language, and this is the way that should be used. Because I never realized that there was another way to do it, an easier way, at least for some cases. And then the easier way is to use really exception likes and using panic and recover, right? And I'm gonna show you how I'm using to work with it, uh, and the rules that we define to work with panic and recover and with errors, the regular error handling in Go. For example, here I have this traditional error handling example. Let me go back there. Syntax issue, as I mentioned this already. You see here, if we go down here, we see a lot of if all the time with AWS code. And just imagine there are some calculations. I saw some statistics on the reduction of number of lines that you have when you are not using this if error syntax. You reduce a lot because you do not repeat yourself all the time, you know? So we have here the traditional way of handling Go, if error, blah, 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 do this. This is the normal way that we use it to. And there is the panic and recover. Who here is familiar with panic and recover for handling errors, simulating exception idea that other language have, that is like I want to interrupt the flow of the execution and return to the caller saying this happened, this stop it here, and catch this and do something.
Yeah, definitely used it.
Perfect.
I do because I work with you.
Yeah. Okay, Venkata, it's true. But okay, here is basically one idea that you can use, and several people use it. But my experience is to having rules to define how to use it, make it a way easier to interact with it, right? So the basic idea is here in your main program or whatever, any place you want to create a try catch, basically, you are doing a defer function that you say, if an error, try to recover it because it will execute this, right? And by the end of, on the finalized section of this function, it will invoke this deferred method, right? Deferred function. And here it will say, okay, if the recover returned anything, and then, okay, I'm assuming here, this is wrong. This is just for the sake of example, okay? Because I have to do more checks. I'm assuming that the recover is giving me an error, then I'm doing a cast to error and I'm panicking, okay? I'm saying, okay, it panicked. And then I am running the program here, doing unit of work. And then I have panic here directly. You see, when I call unit of work, do work will call unit of work, and it will already generate an exception. So it will fail. It will fail with an exception and with panic, right? And this is not quite different because I could comment this out and the outcome would be the same because I'm panicking, right? So it's like panics. But the idea is that we're going to show a little bit further some techniques that you can use for libraries, especially for libraries and private code and public code, or code that you are using in your project and code that you are sharing with other teams or other companies or open source that other people you use. Okay, continuing here. Questions up to now? Panic and recover, traditional error handling. Would it make any difference to do it? Sure, we can reduce a lot this code because we can remove all these if error, if error, if error, if error, if error. We can only call the method because it will be executed and will be handled by the try-catch operation that we are trying to that we define to use. And we can have several levels. We can have one inner catch and an outer try catch, or whatever level we want to get this information and handle this kind of information. So if we compare here side by side, basically when we are using the error mechanism in Go, we are using the regular return the outcome or the output of the function and then the error object to signalize that something went wrong. And when you are not doing it, you are just generating a panic. And then the caller is responsible for attaching a deferred function that will recover from the error and handle the error. Okay? But then, is this already being used a lot? Like, we do this all the time, and some people don't know. For example, if we get here, every time that we are doing any JSON serialization, okay, I think in the Martian function, Unicode state, I think it's here, Marshall, yeah. If you look here, they are using it already for every single thing that they are doing the JSON package. I think the JSON package was the first package for the standard library in Go that is 100% not using the regular if error do this, if error do that. And then I will explain how they do it to connect to external word. That is basically my contention here and the way I like to do it. I learned from this code here how they do it. And yeah, okay, continuing here. I don't want to talk about performance impact right now. Let me just come back here. Yes. If the normal way of we do things, right, is like, as we mentioned already, is do this, if this, do that, do this, if do that. And then this section, this example here, 8 and 9, I explain the difference that I like to implement. I will start with the private one. What I do is the following. Every single function inside my library or my code that is managed by my team, that is not managed by other people in the company or in an open source project that is like just used by the development team, not by the consumers of the API or of the library, whatever. Every single function is using panic and recover all the time. And I don't care, like when I do something, if I want, I have a deferred function here to handle the exception, then I call my function that will call another function that will call another function and another function. And if I want to handle something here then I will handle specifically here. If I don't need to handle anything, just the global one needs to be done, then I don't care about it, right? And this one here is doing the magic. In my example here, for the sake of the example, is just generating an error, generate a panic, right? And all my library, everybody that is working on the team knows this rule. It's like, we do not use if do something, if error, do that. We don't do it. We just call the method because we know that if anything goes wrong, a panic will be raised, and there is a deferred function acting as a catch that will catch the error and treat the error. We can add additional catching blocks to detect this, that something wrong happened in an isolated part of the code, and we should handle it there and not propagate to the upper layers of the application. But we are basically not doing if error, if error, if error. And this is a very good strategy. It reduces a lot of code. It makes it easier and simpler for the developers not to care about error handling there, because we have specific places where the error handling is occurring. We can notify, we can have observability in the same place, we can have log in the same place, we can have traceability at the same place, because we know precisely where we're going to handle the errors when they occur. The problem that some people can raise is like, okay, but when other people are going to use your libraries or the code that you guys wrote, how they will know that they should use the try catch or the recover and panic semantics to handle errors? And this is exactly what we do. Like, every time inside our private library or component, we do not expose errors. We are treating everything with recover, panic, and that's it. But when we want to expose methods that other people will use, we always have this defer thing here that will call whatever it has to call. And when an error occurs, it will recover from the error and will return the error in the normal and regular way that Go programmers are used to handle it. Just like the JSON package is doing, right? It's like, inside our private library, we don't do if error, do this, do that all the time. So we reduce a lot of code. We have a pattern to develop. We know how to do it. We know where to put code to handle metrics, to handle observability, and everything that is related to errors, how many errors happen, load throttling, circuit breakers, and everything, because we know where we are handling this. But when we are putting this to external teams that they do not know or do not follow our standard, because either they don't know about it or they don't want to follow it because they don't agree with it, we make it the regular strategy, that is to return an error, and we give back an error to the team. Does it make sense? And yeah, we have very good success with it, because we reduce a lot the amount of code that we are writing. Also, we make it simple because we have one single place to handle this kind of things. Let's say we have an API, a backend API to develop, and everything, all the business functions that are being called and so on and so forth. Just one unique place is handling and recovering from the normal errors that can occur. And we can handle this very well to give answers back and to log and to have traceability about what's going on. We don't need to be like in every handler, for example, for an HTTP request or SQS request or whatever. We are doing checking for errors and errors and errors and errors and errors. Like, the functions are simply say, okay, if I fail, I will generate a panic, and the handler will handle it. One thing that people ask when they're using this approach is about performance. The first thing people think is like, what about performance impact? This this thing here was created by one person called Rafael Kenna-Boss, that he's a technical staff member in Cockroach Labs, okay? And here in the blue line, we have the Go baseline, okay? We have no errors being returned and how fast the program runs, okay? And when we simulate errors with small numbers of re-executions, we see that using Go errors return up to 6 times, okay? Returning this, we have a performance impact. And after 6 times of returning this, we start seeing that the Go panic outperform the Go errors in the overall performance. And I will explain this later why, okay? I will not get into technical details because I love it, the low level think of this, but it's not everybody that's really passionate about the reasons why. And when we talk about performance, okay, when we get to computational latency and we increase a lot the number of executions, okay, then we get better and better with the performance. We are saying the Go panic gets very, very near the baseline. It's like almost no impact whatsoever. It's like we are reducing a lot of code and we're not impacting the overall performance of the program, okay? I already commented this. And what are the advantages of this? And here I will explain for the skeptical people why this happens, okay? First thing is like we reduce a lot the code, reduce code size. Error not equal new is a poor overhead for the code. No more error equal new or where it should be error not equal new or the other way around. This is me, I do this all the time. Passing arguments and returning value has a cost. This is the first reason in Go why the performance impact, the performance of using panic and recover has a better performance in the overall structural things instead of passing arguments. Because passing arguments in Go, the way Go was implemented, the decision in Go that was changed in Go 1.6, so it's a little better after 1.6, okay? Go does not use registers to store values. It uses direct memory. And by not using registers, it has a performance impact. So every time that we call a function in Go, is different from C, C++. The people with background in C, C++ know that you have like, go to the stack is sent to the registers, and the calculations and computations is all performed on the CPU registers, right? In Go, it's not performed like this. It's really performed in memory, okay? That's a design decision from the Go developers. That this was changed here. If I click here and open this, there is this article that Go 116 will support register-based called convention, and there is a big explanation here and more documentation about why it's changing, why it's better, and why the performance increases, okay? And all the other reason that using panic and recover improves performance and also readability is that all the boilerplate code of all these ifs and so on, they increase binary size and they impact the CPU instruction cache and the CPU data cache, adding unnecessary pressure when the program is being executed. Again, these two last items are very low level, like they are interesting to read because basically if we summarize, like we have more code and there are more cache misses in the instruction set, in the instruction cache and in the data cache. So it has to reread the instruction and reread the data all the time because there's a lot of code that is loaded, unloaded, loaded, unloaded, loaded, unloaded, right? When you reduce the size of the binary, you you reduce the pressure on the instruction cache and in the data cache. Okay? Questions?
Yeah, so I have I see what you're going for, and I see the performance benefits. Of course I'm a go purist in a lot of ways. I do agree about panics should be more common. I think a lot of people are afraid to even use panics and prefer as a conceptual thing. What I worry about as going to it as the de facto like pattern is you don't think about certain things. So take your work statement from before where you're doing step A, B, and C. There's nothing in a programmer's brain to think about, well, if I do A, then B fails, do I like and then do I have to undo A? Like, do I need to walk back A? Like those concepts of like when you have to look and recognize and see in your code, like I got halfway down and this broke. You think a lot more naturally about, oh, I've already done all these things. Whereas I think, I don't know, do you have problems with that? Like I would worry that everyone's going to assume because I'm not returning errors, errors can never happen. So why would we bother worrying about what happens when I'm halfway done with something? Does that make sense? Like that'd be my biggest concern.
Absolutely. It does makes completely sense and it's excellent observation. That's why when I like to present this idea to people and say that this is something that everybody has to agree in the team and understand and define the points where the error handling will occur. Otherwise, it's kind of like a nightmare that you don't know if something fails, who is handling this? I agree with you 100%. That's why the Go standard library team defined a very well established way to do this in the JSON package, and the rules are followed there, and the people that develop it know how it works. And I tend to agree with you. If you have a newcomer to the team, okay, and the person is not used to this approach, right? And there is no onboarding, there is no documentation. People are not explaining how this thing work and the advantages. The person will start changing the code and say, "Oh, this code is completely wrong. We are not treating errors here," and we'll start adding if error, if error, if error. I fully agree with you. It's a very valid point. In our case, it's well documented and well established in our team how we do it, and that's why it works for us. I know that the team from CockroachDB managed to reduce incredibly the number of lines in their code base and improve a lot the performance. But this was something that the entire org agreed, and every single developer that was adopting this pattern was understanding the consequences and how it works. If you are like, if any of you never heard about it, I hope you guys already knew something about this. The idea here is more to have this discussion, but let's say that some of you never heard about it, and then you go back to your company tomorrow and say, oh, I learned something yesterday. This is really cool. I'll start developing like this. Man, it will be a nightmare because it's only you doing this and the entire org not following the standard that you define, right? And it will definitely not work. But when it's agreed within the team, people see advantage. When it's discussed, in our experience, it has a lot of advantages in performance and readability and clarity where the error is handling, okay? Handled and everything. But I agree 100%. This is something that has to be agreed. And there is the caveat of newcomers not knowing about this. We'll find it really strange because people are used to if error, if error, if error, if error. But once they experiment with it and they see the advantage of it, people don't know how to program without this anymore. It's like if I have to program with a lot of if error, I'm like, this is so ugly. My God, why I have to do that? You know? But again, this is something that I got used to, and the entire team is using. But your point is 100% valid.
Okay, yeah, I think it makes sense. Again, I did like the conceptually falling back when you do like inter package and publicly available things is falling back to errors because that makes a clean public interface. So
Yeah, and that's the way that everybody's used it, right? It's like if you're sharing something with the rest of the world that people don't know about this and you don't have time to explain or convince people and they're not convinced that it's a good approach, you're just saying, okay, I will use the normal way that does things. But in our team, we know the advantage and we're going to do like this. And it really works really well. And the performance is incredible. Okay. Last point from my side here.
One more question.
Go ahead. Sorry.
So I was also intrigued by the never use errors. And so I'm wondering if your team thinks about what it means for code to fail differently now that you use panic recover instead of errors. Or is it no change there? Is your design strategy change for when a code should fail, when it should do something else? Or is that not changed? No perceptible change there?
Yeah, one thing, let me see if I got it. You're right. You're asking about if our design strategy or the way we develop or conceptualize the software that we created was changed after we changed the approach of using errors to use panic and recover. Did I get it right?
That's correct.
Yeah, it changed a lot because first of all, we were like, okay, should we have some specific, I'm talking here, not generic software, okay? It was like, we are using a lot in the context of backend development, okay? To handle HTTP requests, UPRS, GPRS requests, or SQS requests, message requests, and all these kinds of requests, right? What changed a lot was we were like, instead of having a lot of places that we are polluting our code, doing error handling, we can have one specific or some specific places that they will recover from errors and they will do it in a consistent way. That's the second part that I will explain, because we created a library to handle our kind of errors. And we completely, when we develop the components and the entry points of the components, we say, okay, here we're going to have an error handler, here we're going to have a error handler, and here we're going to have a error handler. And everybody else in the code, you're like, it's safe because it's already handled. If any new developer come to the code and forget to check anything, we're going to have the error being treated correctly, because we had to get more robust in the error handling, because we wanted to make it easier to develop code without checking it for errors all the time. Did I make myself clear?
Yes, you did. Well, so it makes sense that if you're several layers down in code and code fails and the caller can't do anything about it, and several callers in a row can't do anything about it, you just continue this chain of return error.
Yeah.
It makes sense just to panic and go to the place where you can handle the problem.
It's like when it's very, very good when something goes wrong and there is nothing to do. It's like, okay, that's it, Or there is let's say we are implementing a circuit breaker and then we are receiving a lot of timeouts, and then we are raising timeouts back to the handler, and the handler can activate the circuit breaker because it knows what's going on. And the more the inner components don't need to care about it, because there is a outer component that is handling this for you. But again, this has to be agreed with the team. The design has to be clear, and the things have to be communicated. Otherwise, it can happen that you have one part of the code checking for one specific error and handling it, and somebody that's inadvertently doing the same in the inner part of the code, checking the same error again, So the communication is key here. I hope I answered your question.
You did. So I assume then that if the caller can do something about it, the caller actually handles the recover.
Exactly. That's the point. Yeah. What we learn, exception or better inside APIs or library boundaries. I love DDD, domain-driven design. So every time that I create a boundary, and yeah, I say like this boundary here will do this, but the external world will know about errors. An exception with better performance up to now. Everything can change. I didn't see anything in Go 1.8 that could impact this or could change this behavior. Uh, yeah, but up to now, we are doing okay with it. The last thing that will answer or improve a little your comment is very fast. Is all that I mentioned right now is about syntax error handling, right? And there is another part of development that a lot of people don't really pay a lot of attention. That is semantic error, right? And we love, although we extended this, there is one RFC named RFC 7807 that creates problem details for HTTP APIs. Okay, I'm not going through the entire RFC for sure, but one thing that I like in this RFC is that it creates a kind of entity, okay, that gives you information about the error that is occurring in a standard way. That in all our libraries, we created a error library that all our libraries and then components and frameworks, they are using this error library. So nobody's is like kind of create an error out of the blue, you know? We have our errors to do the things we want, or when there is a operational system error or something, we wrap this error on an error from our library. So the code gets more or less, it's really fast, like this. For example, if I run this, you're going to see that we have this thing here, okay? That is how we handle our errors. And we created this library that is incorporated. Here I have a piece of the entire framework, but here we have this. We have like errors, that is ours. It's in our component, okay? Call it Go Errors. Very creative name. We have errors builder, and we have, first of all, we defined some concepts. One concept was a permanent error, and we have the concept of temporary error. What is a permanent error? Is an error that can, if you retry, will never work, will never succeed without human intervention. There is something that's misconfigured, something's completely wrong, and will never work. So the caller will know that received a permanent error and should not try again because it's not going to work without some human being going there and doing something, you know? So we also, back in the day, I love to have the operational manuals. We create the idea of having IDs for every kind of error. Then we have a big catalog of errors, error codes, and what this error means, you know, like when the operator is going to, not operators because we don't have operators anymore, but when the support people, SRE, or even the dev team is going to check what's going on and it's going to see error 1225, and then they say, oh, this thing's missing. Because every single error that we create a new error code, and everybody knows about this error and know what's going on, and we go through the operational manual. When we have cause, like this was created by something, we say, okay, create our error as a permanent error with ID blah, 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 caused by this error, okay? And then we have this piece of code here in our library that we say, from error, generate the RFC 7807 representation of it, okay? Did I manage to explain the concept? And this is key for us to have this in a clear way that everybody can understand what's going on. You know, like it's like, oh, that's perfect. We can improve our documentation about errors. We have a library. Nobody's going there and say, oh, I'm going to create a crazy error here that nobody knows anything about it. And also, like back in the day when I was basically living Java all my life, I remember that I used to hate when people say this exception is normal. It's really funny to see a system booting up and people saying, oh, this is a normal exception. No, it's not a normal exception. Exception should not occur, right? And with this here, everything we can document, have observability metrics. We have other components that are attached to this error library, and we create metrics, numbers, amount of errors per hour, and everything. Last thing, and I'm done, is just to exemplify here. As I said, we have permanent errors, and here we have temporary errors, okay? And what is a temporary error? A temporary error is a timeout, is something that if you try again, it can be that it works, you know? It's nothing like the database is down. Yeah, it's a temporary error. You can try again and it's gonna work if the database is back up. But it's different from a merchant configuration, for example, that's completely wrong. And you are trying to activate a service or use a service that this merchant doesn't have. You can try 1 billion times and it's never going to work if a human being doesn't do anything to change the status of the configuration. What we can learn from it, errors should have temporary and permanent ideas. Errors should have error codes that are listed in a product operation guide, and they should be described with reason how to fix it or mitigate it. Errors should provide details so the person which is evaluating the problem can get a context and understanding and finally fix it. Yeah, I hope I didn't pass. I used the expected time, but that's what I get.
That was great. That was perfect. Thank you.
That box is in a boat.